Hello there. Let's take a look-see at two graphs. They look the same. The purple, however, is for x, which is position, versus time, which tells us how the position of the object changes with time. The one on the right is how velocity changes. So I'm going to mark it as v in meters per second versus time in seconds. We have thoroughly gone over the x versus t in class today. If you remember, this represents rest. So if I asked you what is the distance traveled in the first 2 seconds, you didn't travel anywhere in the first 2 seconds. The distance traveled is 0 meters. You can even just say 0 without meters. Displacement is also 0. We did not move. Position did not change. There's no displacement. If we are looking at this graph, v at 0, already 4 meters per second. So what we see here is that our object is moving at 4 meters per second for the time of 2 seconds. If we are moving, x is v times t. We're moving 4 meters a second for 2 straight seconds. That is 8 meters. We traveled 8 meters in the positive direction. And if I shade this area and find that area, you remember from geometry that a rectangle is an area of width times length. So width for me is 2, length is 4, and we get 8 meters. So the area under the graph v versus t would give you your displacement. You moved for 8 meters, and you know that you moved forward because your velocity is positive, so you're going in the positive direction. You can think north, east, just forward is good enough. Now let's look at the second question. The second question is asking us what is the displacement between 6 and 10 seconds, and what is the distance? Ultimately, they're going to be the same because we didn't change direction. Let's look at the next question. Be very careful here. What is happening between 6 and 10 seconds? What we see is at the moment in time that is equal to 6 seconds, our object starts moving, and it's moving backwards, and it's moving all the way to 1. Remember, distance is not negative. So if I ask you what is the distance traveled between 6 and 10, you will say it's 3 meters. But if I ask you what is the displacement of the object between 6 and 10, you will tell me negative 3 meters because it's backwards. The slope of this line, of this part of the graph, is negative. That tells us that we're moving in the opposite direction. And we did not dwell on the v versus t at all yet. So I'm going to help you if you want to go ahead and do your homework today rather than tomorrow. The idea is the same. The area under the graph represents your displacement. So I'm looking at this. This, if you remember geometry, is a trapezoid. If you don't remember the area of the trapezoid, that's not a big deal. You can look it up, or you can split it into a triangle and a rectangle. That looks like it's 1 times 4. That's 4 meters. Now we're going to find the area of the triangle, which is this part. So area of a triangle, as you remember, is 1/2 base times height. Base, I'm going to say this is my base, which is 3. Height is this, which is 4, between 6 and 10 seconds. So that's going to be 1/2, 3 times 4, that's a 2, that becomes 6 meters. So altogether, if I add 6 plus 4, this area is 10 meters. There's a shortcut, however. The area of a trapezoid is 1/2 of the sum of the two bases. So this whole base right here is 4, and then that whole base is 1. Because remember, the bases for the trapezoid are the parallel sides. So it's going to be 1/2 of 4 plus 1 times the height. And the height is the time. So that's between 6 and 10. So times 4. So you end up with 5 times 2. That's a 10 meters again. If we are dealing with v versus t, we're going to find the area under the graph for the period of time, and that will give us the displacement. Let's complicate it a little bit. The graph on the left, that's what we worked on in class. You know, this will be rest. This is moving forward. This would be moving back. And if I asked you, what is the displacement between 0 and 5 seconds and between 6 and 10 seconds? So if I'm working with the graph on the left, remember displacement, where did you start? At 0 seconds, I'm right here. At 5 seconds, that's 5. I'm at 8. Displacement from 0 to 5, in this case, is 8 meters with a positive because I moved forward. Between 6 and 10, I started at 8, so that's my initial position, and at 10 seconds, I'm at -4. So change in x would be -4 minus 8, -12 meters between 6 and 10. That is if we have a graph x versus t. We just look at what our x was at each moment in time. Now moving to the more complicated v versus t. Remember before we said area under the graph represents displacement. Now the predicament here is that we have a little bit of a U-turn going on right here. Between 0 and 8 seconds, our object was moving forward because the velocity was positive between 0 and 8 seconds. And then at 8 seconds, we made a U-turn and moved backwards. Because see how velocity is now negative. We're moving back. Here, this was a U-turn because the slope all of a sudden became negative. But in this case, that is a U-turn. So that means all of this is positive displacement, and anything right here is negative displacement. So we moved backwards. But the fact that the area under the graph means displacement is still valid. Only here you will have positive displacement, and here you will have a negative displacement. Returning to the question, what is my displacement between 0 and 5? That's 5 right here. And we have all this area, and I will just go ahead and do the trapezoid formula. My two bases, this base is 3, this base is 5. So I get 3 plus 5 over 2 times, this will be my height, which is 8 times 8. So it's 8 times 4, that's a 32 meters. If I need to figure out the displacement between 6 and 10, that is the most challenging part. So I see between 6 and 8, I have a positive displacement. This area is positive. We were moving in the right direction. And then I have a little sliver here. And of course, it's a trapezoid to make our life difficult. That is negative. This, I can say, that is moving north, and this is moving south. And if I say moving south, that means I have to make that area negative. So let's calculate. This looks like 2. This is 8. So we have 1/2 base times height. 1/2 8 times 2. That gets us 8 meters, and it's positive. So it's positive 8 meters. Between 6 and 8, we moved forward 8 meters. But then from 8 to 10, at 8 seconds, we made a U-turn, and now we have 1/2 base A, which is from 8 to 10, 2, plus this base is just 1 right here. And then I multiply this by the height, and the height is -4. So then you have your -2 times 3, that's -6. So altogether, we moved 8 meters forward, 6 meters back. What's our total displacement? 2 meters. Boom, boom. That would be the answer to question number 15, which dealt with this V versus T graph. I hope this was helpful, and we will go over it tomorrow as well. So don't panic.